So we shall see an example of this grammar. Just now we have seen this grammar already, how to find out the first and follow for the same grammar. Now what is important is, why are we doing this first and follow? So previously we have seen that in order to construct LL1 parsing table, we need something called as LL1 parsing table itself for the LL1 parser, right? So if we have to construct the LL1 parsing table for the grammar, why are we constructing it? It is a top-down parser. The main purpose of top-down parser is, whenever I have two alternatives for a variable, I have to find out, I have to be sure about which production I should use. It depends. See, if I have this production plus t dash, this production is used whenever I want to derive plus. That is why I want to find the first of it, isn't it? And this production is used whenever we don't want to use e dash at all. Whatever is following e, that can generate e. And whenever I have two alternatives, which one should I use? That depends on the first. See, if I have id and e, whenever I see id, I am going to use this production, and whenever I see open brace, I am going to use this production. Therefore, the main use of the top-down parsers is to find out what is the first generated by a symbol. So in this case, the table is going to look like this. What are the variables? Variables are going to be in the rows e, e dash, t, t dash, and f. These are all the variables. And what are the terminals? Terminals in this grammar are, one is id and one is plus, other is star, open brace, close brace, and I am also going to write dollar. Why am I writing dollar here is, there is a chance that we might see dollar in the string, because always the string, the input is going to be ending with dollar. Therefore, I am even going to see dollar in the input, and I might have to take some actions there. So now what does it mean is, if I am seeing at e in the derivation process, and if the symbol that I have to get is id, what is the production that is apt? That is what I am going to write here. Whenever I see any variable, and if I have to generate a terminal, which production I should use? That depends on if the first of that production contains this variable, this terminal or not. For example, let us say this production e derives t dash. Where should I place this one? In the e row. Why? Because we will use that production only when we see capital E in the derivation, isn't it? That is why we have to place this production in the e row. Under which column? That is nothing but first of t dash. Why? Because whenever we want to generate first of t dash, then only I am going to use this production. Now what is first of t dash? First of t dash is nothing but first of t. What is first of t? id and open brace. Therefore, under id and open brace, I am going to write this: e derives t, e dash, and then e derives t, e dash. What is the meaning of this? Whenever you are looking at e, if you have to derive id, you go and use this symbol. Why? The first of t dash is generating this. See, I am not placing it in the first of e. I am not placing it in the first of e. I am placing it in the first of right hand side, because first of right hand side is going to generate the strings actually. The right hand side is going to generate the strings. So I am not going to see the first of left hand side, I am going to see the first of right hand side. Now let's look at this production, this one. Where are we going to place this? In the e dash row. Why? Because whenever we see e dash, I am going to choose this production. Under which column? See this? Now these are the columns. Okay. So where should I place this one is, whenever I am in e dash, I am seeing e dash, and whenever I want to generate first of this entire right hand side. What is first of this right hand side? It is plus. Therefore, under plus I am going to place it, which means e dash derives plus t e dash. So why did I write this? Because whenever you are seeing e dash, and if you have to generate plus, then go with this production. This is going to generate plus. Now what about the next one? E dash derives epsilon. Whenever you have epsilon, what is first of epsilon? Epsilon. Therefore you should place it under epsilon, but then we are not going to place it. The reason is, we are never going to see epsilon in the input. Always there is going to be dollar. So whenever you get epsilon productions, or if the first of right hand side is containing epsilon, then you are going to place this production even in the follow of left hand side. So what is follow of left hand side? What is follow of e dash? Follow of e dash is dollar and close brace, which means here E dash derives epsilon, and then E dash derives epsilon. So why are we placing it at the this follow is, let us say in the derivation procedure I got something like this. I got something like ID E open brace and dollar E dash. Okay, now I want to see what I should use for E dash, whether I could use epsilon or not. I could use epsilon here, epsilon production, provided that the next symbol is in follow of E dash. If the next symbol is in follow of E dash, then I can use epsilon. It is nothing but can you vanish, can you make that variable vanish? You can make it vanish only if the right hand side, if the next symbol in the production is not, the derivation is nothing but follow of that symbol, that variable. Okay, next one is T. Where are you going to place this next production? It has to be placed under T row because left hand side is T and in the first of ft dash. So we are going to place it under the T row and in the first of ft dash. What is first of ft dash? First of F. What is first of F? ID and open brace. Therefore under ID and open brace I am going to write T derives ft dash. Under ID and open brace, T derives ft dash. Next, what about first of T dash? Sorry, this one. Where are you going to place this one? Under T dash row because left hand side is T dash, and under the column star, which means I am going to place it as T dash derives star F T dash here. And what about this one? It has to be placed under follow of T dash because it is epsilon. All the epsilon productions have to be placed under follow of left hand side. What is follow of T dash? Follow of T dash is plus close brace and dollar. Follow of T dash is plus close brace and dollar, which means T dash derives epsilon plus close brace is T dash derives epsilon and dollar is T dash derives epsilon. What about this production? This production has to be placed under first of ID, which is nothing but ID. So here I have to place it F derives ID. What about this production? Its production has to be placed in the F row and first of that, which is open brace, which means F derives open brace E. So this is called LL1 parsing table. So how did we construct it? Given a grammar, first find out the first and follow and take every production and place it in the left side row. So row should be the left hand side and the column should be first of right hand side. So take each production, place it in the left hand side row and the column always should be first of right hand side. And whenever you see epsilon in the first of right hand side, you place the production in the follow also. In case if I would have got epsilon in the this one first of T dash, I will have to place it in the follow of E also. So where should we place a production? That depends on what is the first of right hand side. If the first of right hand side is only terminals, directly place them there. If the first of right hand side contains epsilon, then place it even in the follow of left hand side. If the right hand side is simply epsilon, then place it only in the follow of left hand side. These are the rules. Now why did we do this all? What is the use of this entire table is in order to construct the parse tree. I'll tell you how the LL1 parser works. Till now we have seen the first, the follow and the construction of LL1 parsing table given a grammar. Now I am going to show you how we are going to use this parsing table in order to construct a parse tree. Okay. Yeah, let's see the next grammar. Next grammar is S derives S or epsilon. So this is a simple grammar. Using this I'll show you how to construct the table and then the parsing procedure. Maybe the previous example would have been too big that you wouldn't be able to follow. Let's see what are the variables here. Yes, what is the terminals? Open brace, close brace, and the one more terminal is dollar. Always you are going to write dollar. Now where are you going to place the first production? The first production. So what is this grammar? This grammar is going to generate all balanced parentheses, which means like this, all nested balanced parentheses. Okay. So if I had to place the first production, it has to be kept in the left side. So what is the left side? Yes, and it has to be placed in the first of right hand side. What is first of right hand side? Open brace. Therefore the first production has to be placed under this cell. What about the second production, epsilon? It has to be placed under follow of S. What is follow of S? Dollar and close brace according to this grammar. Therefore under close brace you are going to place this as well as under dollar. Okay, yes. So my doubt is every grammar ready to be used for LL1 parsing? Every grammar may not be able to be used. No, we may not be able to use every grammar for the LL1 parser. The reason is sometimes we might get multiple entries in a single cell. In this grammar we are getting only one entry in one cell. But then in some other cases we might get more than one entry in a single cell. In such cases the grammar is not feasible. So we shall see the example here. Let us say I want to generate this one. Okay, how does LL1 parser work is simply we are going to have a pointer which is going to see one symbol because it is LL1, and always bottom of the stack is dollar and top of the stack is the start symbol. What is the start symbol here? S. Now S on seeing open brace, S on seeing open brace, what is the production? The first production, which means the tree is going to start with open brace, S, and then close brace. So we are going to use this production. Therefore replace S with this right hand side so that the leftmost symbol will appear on the top, which means I am going to write it as close S open brace. Now top of the stack is open brace and input is open brace, therefore there is a match. Whatever you wanted to generate, you generated it. That is why pop off the stack and increment the input pointer, right? And now what is that we want close brace, and what is the symbol we are looking at? Yes, open brace, and what is the symbol we are looking at? Yes. Now S on open brace is again the same production, open brace, S, and close brace, which means S has to be open brace, S, and close brace, which means this S has to be open brace and then S and then close brace, so that open brace will appear on the top of the stack. Therefore close brace, S, and open brace will appear on the top of the stack. Now see this, open brace and open brace, there is a match, therefore pop off the input symbol, pop off this open brace and increment the input pointer. I incremented it. Now S on close brace, what is S on close brace? See that production, S on close brace is simply epsilon, therefore S on close brace is epsilon, which means pop it off. Close brace on close brace, there is a match, therefore pop it off and increment it. And again close brace on close brace, there is a match, pop it and increment it. Dollar on dollar, therefore it is accepted. You understood it? Or if you want to see one more example, you can trace it out. You can start with this. Always remember that LL1 parsing algorithm is going to start with dollar in the bottom of the stack and dollar at the end of the input. Whenever we see dollar, we can say that it is successful matching. Otherwise we are going to consult the table. Now the next question is every grammar, using every grammar we can construct LL1 parsing table? It turns out that for some of the grammars we will not be able to construct LL1 parsing table. The reason is we might get multiple entries. So what is the meaning of each entry here? When you see a variable and when you see a terminal, which production to use? If you can predict it so well, then only it is called predictive parser or top-down parser. But then if you have more than one entry here, there is a confusion about which one to use. Therefore such kind of grammars we may not be able to use it. Okay. Let's construct the LL1 parsing table for this grammar. You can look at, you can pause the video and have a look at it. The grammar is S derives A, B, 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 A, and then A derives epsilon and B derives epsilon. So for this grammar, if you look at it, the terminals, the variables are going to be S, A, B. Therefore rows in the LL1 parsing table are S, A, B, and the columns are terminals. What are the terminals? A, B, and dollar, right? So where should we place the first production? S derives A, B. It has to be placed under S row, this row, under what column? Under first of the entire thing. So what is first of this entire thing? First of this entire thing is first of A. First of A is epsilon. If I put epsilon, I get small a. Therefore that production has to be placed under small a. Why? First of right hand side is simply small a. Then what about the second production? This one, where should I place it? In the first of right hand side. The first of this entire thing is first of B, and the first of B is small b. Therefore I am going to place it here. S derives B, 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 A. And what about this A derives epsilon? It has to be placed under follow of A. What is follow of A? Small a, small b, which means A derives epsilon and A derives epsilon. And where should I place the next one? Third production in the left hand side is B, and in the follow of B, what is follow of B? Small a and small b. B derives epsilon and B derives epsilon. Therefore, in every entry we got only one production. In every cell we got only one production. Therefore, this grammar is LL1 and it could be constructed. But then there are some grammars for which LL1 parser cannot be constructed. The reason is the parsing table might contain more than two entries. So it is worth noting that any grammar which is left recursive cannot be used for LL1, and any grammar which is non-deterministic cannot be used for LL1. So you have to eliminate the left recursion if you want to use it for LL1, as well as you have to eliminate the non-determinism by using left factoring. And there are some other grammars which are not left recursive and which are deterministic, still they cannot be used for LL1 parsing table. The reason is we might get more than one entries. For example, if I have an entry like this, if I have a grammar like this, A derives alpha 1, A derives alpha 2, A derives alpha 3, so on, alpha n. Now all these productions have to be kept in the same row. What is the row? A, right? And let us say we have terminals A, B, C, D, so on. Now, if where should I place this alpha 1, A derives alpha 1? In this row only, in A row only, under one of these terminals, whichever is first of alpha 1. If whatever is first of alpha 1 happen to be first of alpha 2 also, then these two productions have to be placed in the same cell. That is the reason why we might not get LL1 parsing table for all the grammars. The reason is sometimes we might have to place two productions in the same cell if they are having the first same. If this grammar has to be LL1, then alpha 1, first of alpha 1, first of alpha 2, first of alpha 3, so on, first of alpha n, all of them have to be mutually exclusive. Mutually exclusive means there should not be any common part in the first of all this. Are there any possibilities for which we might get more than one entry? Is if I have a grammar like this, A derives alpha or epsilon. These two productions have to be placed in the A row only. This production is going to be placed under first of alpha, and this production is going to be placed under follow of A. If in this case first of alpha and follow of A, they are having intersection, then both of them ought to be placed in the same row. Therefore, we might get non-LL1 grammars whenever we have whenever first of alpha 1, first of alpha 2, so on contains something in intersection, or if I have any grammar of this kind whenever first of alpha and follow of A are having intersection. Let us take some examples and see whether they are LL1 or not. Okay, now we shall test that. Let's see some more examples and check out whether they are LL1 or not, whether each grammar is LL1 or not. So when a grammar is not LL1 is if a left hand side, if a variable is having more than one alternative and more than one alternative wants to get into the same entry. So in this case I have three alternatives, right? So in case if any of the alternative wants to get into the same one, then it is not going to be the LL1, right? So what is this row in which you want to place this production? Under S row only. What is the column in which you want to place this one? Under first of this one. What is first of this? Small a. And what about this one? First of this entire thing is small b. And what about this one? We are going to place it under follow of S. What is follow of S? Both small a and small b and dollar. Therefore, already I am placing one production in A and one production in B, and the third production is going to be placed both in A and B. That is why this grammar is not LL1, and even the reason is it is ambiguous. Yes, it is not LL1, and moreover it is not ambiguous. Now let's see the next one. So whenever we have only one production in the right hand side, you need not check about it, because you can, even if you place this production in the entire row, no one is going to compete with this. Therefore, this has to be actually placed under S row and in the column of small a, but don't worry about it at all, because there is only one alternative, so there is not going to be more than one alternative because of this row. And in this row there could be a problem. See this, where are you going to place the first production? First production has to be placed under C column, A row. And where are you going to place the second production? Second production has to be placed under follow of A. What is follow of A? Follow of A is first of BB. What is first of BB? First of BB is D, because of this, and if I place epsilon here, B. Okay, so the first production has to be kept under C column, and the second production has to be kept under B and D columns. Fine. What about this one? This first production has to be kept under D column, and the second production has to be kept under follow of B. What is follow of B? Small b. Therefore, even though we have more than one alternative for a variable, all of them are going to be placed in a different cells. So this is LL1. This grammar is LL1. This grammar is not LL1. Let's see about this. Whenever we have more than one alternative, we have to think about it. When there is only one alternative, we need not think about it at all. Here we have more than one alternative, right? So where are we going to place the first alternative? In S row. And what is the column? Under small a. Therefore, first one has to be placed under S row and small a column. What about the second one? Under S row only, and the column is small a. Therefore, intersection is there. So it is not LL1. The reason is both of them are going into the same cell, right? And in fact, this grammar is also ambiguous. This grammar is also ambiguous. So you should understand that no ambiguous grammar is LL1. That is what you should understand. And coming to this one, there are two alternatives. Therefore, you have to check the first. Where are we going to place the first one? Under small a. Where are we going to place the second one? Under follow of S. What is follow of S? Dollar. Follow of S is 1 because of dollar, because it is the start symbol. And then follow of S is follow of C. Follow of C is follow of B, and follow of B is again follow of S, which is nothing but dollar, right? So there is no problem with these two productions, because one is going into A and other is going into dollar. What about the next one? This is going to be under B, because first of this one is B, and this one is follow of B. Follow of B is follow of S. Follow of S is dollar. And what about the third one? This one has to be placed under C, and this one has to be placed under follow of C. Follow of C is follow of B. Follow of B is follow of S. Follow of S is dollar. So there are no intersections at all. And one more thing you should understand it, you should never compare two productions which are having different left hand sides. You have to compare only two productions which are having same left hand side, because they are the ones which are going to go into the same row. If the productions are getting into the same row, then there is a chance that they might even get into the same column and there is a conflict. But here, when these left hand sides are different, you need not worry about it at all. Okay, there is only one production, so you need not. So this grammar is LL1, and in this case there is only one production. Don't worry about it. And here there are two productions, and this production is going to be placed under first of right hand side, which is A, and this production has to be placed under follow of A. What is follow of A? Follow of A is small b, and follow of A is follow of S. Follow of S is dollar. And what about this one? The first production has to be placed under small b, and second production has to be placed under follow of B. What is follow of B? Follow of B is follow of S. What is follow of S? Follow of S is dollar. So if you see them, they have arranged themselves beautifully without any conflict. Therefore, this grammar is LL1. And next one, coming to this grammar, the first production has to be placed under first of this right hand side, which is nothing but small a, and the second production has to be placed under follow of S. What is follow of S? First of A. What is first of A? It is C, as well as it is C and even more. First of C. Follow of S is first of A, which is C, and then if you place epsilon here, follow of S is follow of S. Already follow of S is dollar, right? And what about the second one? This has to be placed under C, and this has to be placed under follow of S. What is follow of S? This has to be placed under follow of A. Follow of A is follow of S. What is follow of S? Follow of S is first of A. First of A is C. Okay, again slowly, see this. Where are we going to place this production? This production has to be placed under C. Yes, that is why I placed under C. And then it has to be even placed under, this second production has to be placed under follow of A. What is follow of A? Follow of A is follow of S. What is follow of S? Follow of S is first of A. What is first of A? It is going to be C. Therefore, I have to place it under C and C. The first production also in the S row and C column, and the second production is also under A row and C column. Therefore, there are multiple entries. This grammar is not LL1. Okay. And now this one, there is only one alternative. Don't worry about it. There are two alternatives. Just see. What about this one? We have to place it under first of BB. What is first of BB? One is small a because of this one, and if I place epsilon here, I get small b. And what about this one? It has to be first of CD. What is first of CD? One is small c, and if I place epsilon here I get D. Okay, so there is no problem with these two productions, both are being placed in different columns. Now what about this one? Where should I place this one? This one has to be placed under first of A, which means this one, and this one has to be placed under fall of B. What is fall of B? Fall of B is small b. Therefore there is no problem with these two productions, they are going into different cells. What about this one? This one has to be placed under first of C, which is nothing but C, and this one has to be placed under fall of C. What is fall of C? Small d. Got it? What about this one? This one has to be placed under small a, and this one has to be placed under fall of S. What is fall of S? Dollar. And what is fall of S? Fall of S is fall of A. Fall of A is small a. Check this. First one has to be, this production has to be placed under A, and this production also has to be placed under A. Therefore, there are multiple entries. This grammar is not LL1. Now check this one. Where are we going to place this first production? This first production has to be placed under I. What about the second production? Under A. Therefore, there is no intersection. There is no problem with the first two productions. Now, what about this production? This one has to be placed under E. The first production has to be placed under E, and the second production has to be placed under fall of S dash. What is fall of S dash? Fall of S dash is fall of S. What is fall of S? Fall of S is first of S dash. First of S dash is again E. Therefore, there are multiple entries, which means both of them are going into the same entry E. Again, listen to this. Where are we going to place this one? For first of E, that is why I am writing E. And where are we going to place the second one? It has to be placed under fall of S dash. What is fall of S dash? Fall of S dash is fall of S. What is fall of S? Fall of S is first of S dash. What is first of S dash? Again E. Therefore, this grammar is also not LL1. So we have seen that a grammar is not LL1 whenever we get multiple entries. We might get multiple entries in two cases. One case is if I have A derives alpha 1, alpha 2, alpha 3, and if any one of them are having same first, alpha 1 or alpha 2 or alpha 3, then it is not LL1. And the other case is if I have A derives alpha or epsilon, I find the first of alpha, and for this one fall of A. If first of alpha intersection fall of A is not 5, then also it is not LL1. Okay.